Good morning, ladies and gentlemen. I'm Kwanho from Department of Robotics Engineering at Yeungnam University. Lastly, thanks to Share and all attendants for making this wonderful time to share ideas. Today, I'm going to talk about force control without physical force sensors for using in developing winding equipment. Sorry. Yeah. The content will be followed in order. For the research background, the reason for research and development of different type of a winding machine is to decrease the cost of a hydrogen electric fuel cell vehicle, or HEFCV. To decrease the cost of the HEFCV, PARC in 2019 analyzed that not only developing expensive new material, but also being independent on foreign technologies for manufacturing a high-pressure hydrogen vessel will be required. The vessel is composed of a non-metal linear and a metal module winded by composite carbon fiber layers to contain high-pressure fuel, which is hydrogen. The vessel has two remarkable features. One is high-density carbon fiber layers, and the other is a complex curvature. As for winding machines, existing winding machine on the left figure on the slide, it has a single tip moving and rotating during winding sequence. It has advantage in simple control and structure for the machine, but there is a disadvantage in long winding time consuming. To solve the cons, the latest machine on the right side of the slide has multi-tips to decrease winding time. For example, the machine has a 96 tips. However, the machine has still some drawback with size and complex control approach. I'll continue it. Moreover, both machines utilize wet and dry winding approach, which can offer the winded vessel to be routed. Both two different winding approaches use torsion control of the carbon fibers to make the high density of the carbon fiber layers on the vessels. And the winded vessel must be heated to harden the carbon fiber layers. During heating, if the density between layers is low, air can be located between the layers, empty space, and it could lead making cracks. Consequently, the more cracks are made, the weak vessels are produced, so the possibility of the vessel rupture increases. To resolve the issues, a new developing winding machine has pressing process to make high density of the layers with multi-tips, but not too many tips like 96 tips. To control pressing force, clearly using a force sensor is required. However, due to multi-tips, a lot of moving carbon fibers are hanged, and so reduce the number of wires is important. At the same time, due to stacking the layers, the end effector should move to the opposite direction from the force direction. In short, our research team decided to develop a force control approach without using a force sensor. For now, for the hypothesis of the virtual control. To control force without a force sensor, our team set a hypothesis named virtual wall control approach. In the figure, the hand and the wall in the first picture describe the end effector and the surface of the layers, respectively. The main point of the control approach is the wall is fixed in one point. In position control aspect, if the hand locates right on the wall, a position disturbance would be almost zero. During generating pressure force, the position reference for the hand will be increased, but in the real state, the position of the hand cannot be moved because of the fixed wall. To know the requirement of position input value to control force, if the position reference reference form is converted to disturbance form, then controlling the position of the hand is possible in the virtual state. Therefore, because the physical properties are the same both in the real state and the virtual state, by calibration the virtual spring constant, estimating reaction force in the real state may be possible. And for the control algorithm, to control the position of the end effector precisely, both a disturbance observer and a feedforward for the perfect tracking controller is used. Controlling precise position control is important because the initial position error affects to the force error directly. To control the force reference form is converted into the disturbance form. To convert force level to distance level, a load cell is used as like doing calibration between the force and the disturbance level. The reason for not calculating all physical parameters in the disturbance, but calibration in output value, is to use this algorithm in common in any situation. From the desired force reference, making force error between estimated disturbance and desired disturbance is possible, and by updating position reference into the position controller, force control is working. To verify our hypothesis, the experiment model was made. We want to point out that the load cell was only used to check the force generated in real time. The result of the relationship between the force and the disturbance was deduced. Despite the result was not linear, so linearization was operated. The force experiment outcome looked quite good. However, we designed the virtual wall controller as like an integral form, so that the higher force generated, the slower convergence time happened. For our future work, our team has been working on controlling a linear motor with a force control algorithm. Additionally, because the developing winding machine has virtual feature, a gravity compensation control approach has to be applied. In short, our team studies the way to control force without using any physical force sensor. By the virtual wall hypothesis, disturbance observer, precise position control, and collaboration between the disturbance and the reaction force control was available. For now, our research team is working on controlling force through the linear motor system. Thanks for listening to my voice. Do you have any questions?
Please raise your hand if you have any questions.
And additionally, I apologize a little bit mistakes with controlling all the computer systems. And please give me any questions.
If you have any question, I think we don't have what 함수 can,
If you have any questions, please send me email or contact me. I'll really pleasure to getting any questions. Thank you very much.